Welcome to the Vibes Lab, your front row seat to the science behind VIA, the Vibes AI agentic platform making everyday brain health accessible to all. Every episode is designed to reveal insights that will enhance your cognitive health and well-being. Follow us to grab your lab key and experience limitless intelligence.
Welcome back to the Deep Dive. Our mission today is to take a really hard look at the solution side of a massive global health crisis. We're leveraging the deep sources we have here.
Exactly.
We recently explored something that was just, truly stunning. The finding that voice biomarkers can detect cognitive decline up to 7 years before a clinical diagnosis.
With over 90% accuracy.
90%. It's almost like seeing the future.
Yeah.
But, it immediately brings up this almost existential question from the source material itself.
Right.
Detection without intervention is, tragically, just diagnosis without hope. So this thing is coming down the track, but what do you actually do about it?
And what we do is realize that we're running headfirst into a bottleneck.
Yeah.
We are currently facing what the research really aptly calls the triple brain epidemic.
Okay.
And this isn't just one crisis of the mind. It's three distinct, massive, and converging crises that are just overwhelming our health infrastructure.
Okay, let's unpack this. I think we need to define the scope of the problem we're really up against. What are the three pillars of this epidemic?
So the first pillar is the one we've known about for a long time.
Uh-huh.
The crisis of mental illness. We're talking about 1 in 5 Americans affected every single year.
1 in 5.
The treatment costs are over $280 billion. And the standard treatments, things like antidepressants, they're vital, but they take 4 to 6 weeks to even start working.
And that delay alone, 4 to 6 weeks when someone is in a real crisis, that feels like, an unacceptable gap in care.
It is. And on top of that, they fail 40% of patients who try them, and they often come with a heavy side effect profile. They're not a scalable population-level solution.
Okay, so that's pillar one. What's the second?
The second is the looming threat of cognitive decline. By 2050, the projections show 13 million Americans will be affected. The cost of Alzheimer's alone is projected to hit an astounding $1 trillion annually.
$1 trillion. And we have new FDA-approved treatments, which is great news, but I hear they're not a silver bullet.
Not at all. They cost around $26,500 a year. And what's worse, the infrastructure needed to even deliver them is, for most people, non-existent.
So the logistics, the delivery is the failure point, right?
Absolutely. The source notes that only about 8% of eligible patients can even access these new treatments.
Wow, 8%.
Because they require this specialized infusion infrastructure that's only concentrated in major urban hospitals. It creates an immediate, massive equity issue.
A huge systemic access bottleneck. Okay, and the third crisis is the one that probably affects every single person listening every day.
That's the modern plague. Digital overload. Neuroscientists have a term for it. Continuous partial attention. If you look at your screen time report, and I know I do with a healthy dose of shame.
Oh, we all?
The average American is spending over 7 hours a day glued to screens.
Yeah.
Just constantly shifting focus.
7 hours. Yeah, that checks out. I'm embarrassed to look at my report every week. But I didn't realize that just browsing social media is cognitive fragmentation. What does that actually feel like in the brain?
It feels like chronic stress. This constant fragmentation, it measurably degrades your critical executive functions. It severely hampers memory consolidation.
Because your brain never gets a chance to just settle and file things away?
Exactly. And it keeps your stress hormones perpetually elevated. So these three crises, mental illness, cognitive decline, and digital overload, they're all interconnected. They're manifestations of a brain that is, it's literally under siege. And our current solutions are failing because they just can't handle the sheer scale.
So if we know that things like medication, traditional talk therapy, exercise, if we know these things are scientifically proven to work, why aren't they solving this giant crisis?
It comes down to three fundamental gaps that the research identifies. Gaps that our existing solutions just cannot bridge. We've already touched on the first one, the temporal gap.
Right, the slowness. Pharmaceuticals taking weeks to kick in.
Exactly. They're too slow for acute relief. But even more critically, they focus entirely on the symptomatic phase. They completely miss that 15 to 20-year preclinical window where prevention is actually possible.
That's the difference between fighting a fire and building a fire break, isn't it?
A perfect analogy. By the time symptoms appear for cognitive decline, a lot of damage is already done. We need continuous support across those decades.
Okay, now let's go back to the logistical failure, the second gap.
That is the access gap. Current interventions demand resources that are unavailable to millions. The data here is just stark. 68% of rural counties in the U.S. lack a single neurologist.
68%.
Therapy is incredibly expensive. We're talking $100 to $200 a session, often without insurance. That's just not sustainable for long-term mental health.
So we have a problem of being too slow and a problem of being too exclusive. But this third gap is, I think, the most profound one, the mechanism gap. Why do the interventions themselves often fail the very people who need them most?
This is the crucial and really tragic paradox. Think about the most effective treatments we have. Regular exercise, cognitive behavioral therapy, mindfulness.
Right.
All of them require intact cognitive and physical capacities. You need motivation. You need executive function to plan your week and get to your appointments. You need energy.
But if you have severe depression, motivation is the first thing to go. If you're struggling with that digital overload, your executive function is already compromised.
Precisely. The research shows this clear pattern. These excellent, proven solutions work best for the people who are least affected by the severe challenges.
Because they still have the internal capacity to actually engage with the treatment.
The illness itself has already compromised the patient's ability to use the tools designed to fix it.
That's a devastating structural failure. If the tool requires the functioning capacity that the disease has already stolen, then you need something else, something that bypasses voluntary participation entirely.
You do.
We need an intervention that's continuous, gives immediate physiological effects, and critically offers a passive benefit. Does something like that even exist?
It does, and it's something we've been surrounded by for millennia. The research shows that sound is the intervention that can fill all three of those gaps at the same time.
The idea of sound as medicine isn't new, of course. It has this deep connection to ancient history. Does modern neuroscience actually validate what ancient cultures seem to understand instinctively?
It absolutely does, and the source material calls this the ancestral intelligence of sound. Cultures all over the world, totally isolated from each other, independently develop therapeutic uses for specific acoustic patterns.
Which suggests it's tapping into something fundamental in our neurobiology.
Exactly.
Yeah.
Give us some examples that aren't just, folklore.
Certainly. Take Tibetan singing bowls. Modern studies now confirm that the resonant frequencies they generate can improve mood, sleep quality, and crucially enhance heart rate variability, or HRV.
And HRV is a key measure of nervous system resilience.
Right. Then you have shamanic drumming. This was often done at frequencies around 4 to 7 hertz. We now know that perfectly matches the brain's theta waves.
The waves essential for memory consolidation and meditative states. So they were hitting specific brainwave frequencies without even knowing what a brainwave was.
Precisely. And in India, the tradition of ragas developed into what they called a sophisticated acoustic pharmacopoeia. Melodies designed to shift specific emotional and physiological states in a predictable way.
That convergent evolution is really powerful proof.
So if sound is the answer, how does modern science explain why it works where, say, a pill or a workout program might fail? What are the unique characteristics?
Sound operates through 3 characteristics that are just fundamentally different from traditional modalities.
Okay, start with how it bypasses that need for motivation.
That's the first one. Direct neural entrainment. External acoustic rhythms can synchronize your brain oscillations without you having to do anything. No cognitive effort, no attention, no voluntary participation.
So you don't have to believe in it, you don't have to be motivated, the brain just responds passively.
Exactly. That addresses the mechanism gap perfectly. It offers passive benefit.
Okay. And what about that immediate physiological shift that we need?
That's number 2, passive autonomic regulation. Certain frequencies can activate the vagus nerve, that's the superhighway connecting your brain to your organs,
And that immediately shifts you out of fight or flight.
and into the desirable rest and digest state. It's an instantaneous, non-conscious physiological shift toward calm.
And finally, solving the access gap. Infinite scalability.
Yes.
Yeah.
This is the beauty of it. These interventions work through devices 92% of Americans already own. They're smartphones.
Right.
No specialist appointments, no insurance paperwork, no new clinics. You can reach millions of people simultaneously at virtually zero marginal cost.
Okay, let's get into the technical science now. How accurate is this idea of neural entrainment? Is the brain really a kind of tunable electrical instrument?
It absolutely is. Your brain operates via these synchronized electrical oscillations, brain waves, and acoustic stimulation can control the timing of when your neurons fire with the precision of under 10 milliseconds.
10 milliseconds. So it's like real-time external control over the brain's electrical clock.
It is a great example from the research. If you present 40 hertz auditory tones to someone, you produce phase-locked 40 hertz oscillations in their auditory cortex within seconds.
And that effect spreads.
It spreads. It ripples out to frontal and parietal regions that are linked to attention and memory. It's an electrical chain reaction started by sound.
What about binaural beats? For a long time, those felt a bit like a wellness fad. Is there rigorous science behind them?
The science is there, and it's a really elegant use of that entrainment principle. Binaural beats are basically a trick you play on the brain. You play two slightly different frequencies in each ear, say 200 hertz in the left, 210 on the right, and your brain perceives a phantom beat at 10 hertz, a beat that isn't physically there.
So your brain literally creates the beat. And what are the measurable results of that?
A big meta-analysis of 22 studies found that binaural beats significantly reduce anxiety. And theta frequency beats, they've been shown to enhance memory consolidation.
So it's a non-drug way to shift your state of consciousness. Let's move to stress reduction. You mentioned the vagus nerve. Vagal nerve stimulation VNS is serious medicine. It often involves surgery.
Right, for conditions like epilepsy or treatment-resistant depression.
Are you saying sound can mimic that without ever breaking the skin?
That's what the emerging research is showing, yes.
Yeah.
VNS is FDA approved, but it requires an implanted device. The breakthrough is that non-invasive sound, specifically low-frequency vibrations in the 70 to 120 hertz range, can activate these exact same pathways.
So it's neuromodulation without the scalpel. That's a huge advantage. But how do we prove this shift from fight or flight is actually happening? What's the objective metric?
Heart rate variability, or HRV. That's the metric. It measures the variation in time between your heartbeats. And studies using just 20 minutes of this vibroacoustic stimulation show an increase in HRV of 15 to 25%.
That's a direct, robust measure of the body shifting into a rest and restore state.
It is. And the research goes even further, linking this to reducing inflammation, right?
Yes. Chronic inflammation is a hallmark of stress, aging, cognitive decline, you name it. And sound has been shown to measurably reduce inflammatory biomarkers. We're talking cortisol, IL-6, TNF-alpha.
The chemical messengers of stress.
Exactly. And the effect sizes are comparable to what you might see from some pharmaceutical anti-inflammatory drugs, but delivered passively through your phone.
Now let's talk about what might be the most revolutionary finding in the sources, moving from wellness into actual disease modification. The 40 hertz gamma rhythms in Alzheimer's.
This is really the frontier. We know that gamma rhythms, this high-frequency electrical activity linked to higher cognition, are disrupted years before Alzheimer's symptoms even show up.
And the MIT research here is the key. Tell us what they found when they exposed mice to these 40 hertz tones.
This is just incredible. The MIT researchers found that exposing transgenic Alzheimer's mice to 40 hertz auditory tones reduced the amyloid beta plaques by 50% in the auditory cortex.
50%? Hold on, that sounds like a magic bullet. If research shows a 50% reduction in a major hallmark of Alzheimer's, why isn't this front page news? What's the catch?
The immediate catch is always the translation from a mouse model to a human. That's the biggest hurdle in medicine.
Yeah.
But the mechanism they identified is why it's so exciting.
Which is?
The sound activates microglia. These are the brain's immune cells. And it basically prompts them to get more active and clear out those pathological proteins. It's cellular disease modification, not just symptom management.
That's a critical distinction. It's telling the brain's cleanup crew to get to work.
Yeah.
Has this been tried in humans yet?
Yes. Early clinical data is emerging. A human pilot study using 40 hertz auditory and visual stimulation for 3 months showed that participants slowed their cognitive decline by 83% compared to historical controls.
83%. Now, pilot studies have to be taken with caution, but the size of that effect is massive.
It suggests there's huge promise here. And finally, let's bring it back to the bedrock of brain health. Sleep. Can sound optimize our sleep when we're completely out?
Absolutely. The goal is to enhance deep sleep, which is critical for memory and for the brain to clear out waste. So there's something called auditory closed-loop stimulation.
What does that do?
It delivers precise sound pulses, often pink noise, that are phase-locked exactly to your slow-wave oscillations during deep sleep.
So it's listening to your brainwaves in real time and timing the sound perfectly.
Precisely. A study with older adults, 60 to 84, showed that just 2 nights of this improved their word pair recall, a measure of memory, by 25%. It also increased their slow wave activity by 15%.
Right.
All without waking them up.
It's supercharging your brain's natural restorative processes.
Exactly. So sound hits every major point. It controls electrical rhythm, manages stress, reduces inflammation, enhances cellular clearance, and optimizes sleep.
Let's pivot now to the massive strategic potential here. Prevention.
This is where sound transitions from being a novel treatment to a societal imperative. Like we said, Alzheimer's begins 20 years or more before the first symptom. We just don't have scalable passive tools for that multi-decade window.
And the economic case for prevention is just impossible to ignore.
Completely. The analysis showed that just delaying Alzheimer's onset by 5 years would cut the prevalence by 50% and save $367 billion a year.
Sound provides a continuous, scalable way to manage those risk factors: stress, poor sleep, inflammation during your 50s and 60s when those silent brain changes are starting.
With such compelling evidence published in top journals like Nature and Cell, why isn't sound therapy already the default intervention? Why is clinical adoption so slow?
I think the biggest barrier is what the sources identify as the woo-woo problem. The legitimate research has been, unfortunately, really diluted by the broader wellness industry.
Right, pseudoscience and unvalidated claims everywhere, which makes doctors and clinicians rightly skeptical.
That's a fair point. If the field is full of snake oil, it hurts the credibility of the real science. How do we distinguish between them?
The distinction is neuroimaging confirmation. The rigorous interventions use acoustic parameters that are proven to produce measurable changes in objective data like phase-locked brainwaves or quantified HRV shifts. It's about separating the science from the speculation.
Okay, what's the second barrier?
The personalization problem. The brain is incredibly unique. Most consumer sound apps are one-size-fits-all. They ignore your individual neural variability.
What do you mean by that?
Well, say you have a naturally high level of alpha brainwaves. If a generic relaxation track tries to boost your alpha waves even more, it can backfire. It can cause agitation instead of calm.
So if it's not tailored to your specific neural fingerprint, it's just a gamble.
Exactly. And that leads to the final critical barrier, the feedback gap. You can't optimize what you can't measure.
Right.
The medical model demands a rigorous loop: diagnosis, intervention, outcome assessment, and then adjustment. Most consumer apps are missing that feedback loop. Without measuring your HRV, your sleep architecture, or using cognitive tests, you can't clinically validate that the intervention is working for you.
So for sound to really transform healthcare, it needs to marry that pure cellular level science like the 40 hertz entrainment with sophisticated acoustic artistry and deep personalized data. It needs to feel like medicine, even if it sounds like music.
That synthesis is the challenge. It demands deep expertise in both peer-reviewed neuroscience and masterful acoustic design. The goal is to translate that cellular precision into an experience people will actually use day after day for the decades needed for real prevention.
So what we've really established is that sound, when it's rigorously designed and personalized, acts passively on the brain's electrical substrate. It provides immediate physiological shifts, and it carries genuine disease modification potential. It fills the gaps where traditional medicine is too slow, too expensive, or just plain inaccessible.
And this convergence that we're seeing of early, highly accurate detection from things like voice biomarkers and this scalable, passive intervention with sound, that really represents the future of population-level cognitive health.
It's all there.
Given that this tech works through devices 92% of Americans already own, the infrastructure for mass prevention already exists globally. We don't need to build more hospitals. We need to deploy software. The real challenge is translating that cellular precision to a global scale. So I'll leave you with this thought. What does it mean for society when the most powerful tool for improving brain health is no longer a multi-billion-dollar drug, but personalized, expertly designed sound delivered through the smartphone you already hold in your hand? That changes everything.